Have you ever looked up at the night sky and seen a shooting star? It is a tiny piece of space rock burning up in our atmosphere. Now imagine a rock much bigger. We call these asteroids. They are giant chunks of rock and metal that travel through space. They are not planets and they are not moons. They are leftovers from when our solar system was born, about 4.6 billion years ago. These ancient objects are like time capsules holding secrets about how everything around us, including our own planet, came to be. They silently orbit the sun, following paths that sometimes bring them very close to Earth. Most asteroids live in a place called the asteroid belt. This is a huge, donut-shaped region in space located between the orbits of Mars and Jupiter. Think of it as a cosmic highway full of countless space rocks, ranging from the size of a small car to nearly as big as a small country. While most of them stay within this belt, minding their own cosmic business, sometimes things can change. The powerful gravity of the giant planet Jupiter can nudge an asteroid, like a gentle push in a crowded room. This small push can be enough to send an asteroid on a new path, one that might cross the orbit of Earth. Not all asteroids are the same. Some are made mostly of rock and clay, while others are rich in valuable metals like iron and nickel. A few even contain water in the form of ice. Scientists study them to understand the building blocks of planets. By analyzing the light that reflects off their surfaces, we can learn what they are made of without ever having to visit them. These celestial wanderers are more than just rocks. They are pieces of our solar system's history, floating through the vast emptiness of space, each with its own story to tell about the universe's creation. It's important to know that most asteroids are very far away and pose no threat to us. The universe is a very big place, and the chances of a large one coming our way are small. However, small is not the same as zero. The history of our planet shows that big impacts have happened before. The most famous one is the asteroid that likely caused the extinction of the dinosaurs millions of years ago. That is why we study them. We want to understand their paths, their sizes, and their compositions. So we are never caught by surprise by one of these cosmic visitors. Imagine a day just like today, June 7th, 2025. Suddenly, news alerts flash across every screen. A giant asteroid, one that is miles wide, is on a direct course for Earth. The initial feeling would be disbelief, followed quickly by a deep, cold fear that would spread across the globe. This would not be like an earthquake or a hurricane, which affect only one region. This would be a global event, a challenge for all of humanity. The sky, our familiar blue ceiling, would suddenly hold a terrifying secret. The approaching asteroid would become the most watched object in human history, a tiny dot growing larger and brighter with each passing day. As the asteroid entered Earth's atmosphere, it would be a sight of both terrible beauty and ultimate destruction. It would blaze brighter than the sun, a fiery messenger from the cosmos. The impact itself would be unimaginable. It would strike with more force than all the world's nuclear bombs combined. The explosion would create a massive crater, instantly vaporizing everything for hundreds of miles around. Giant earthquakes would shake the entire planet, and tsunamis, waves taller than skyscrapers, would crash into coastlines around the world, washing away cities and reshaping continents in a matter of hours. The immediate devastation would only be the beginning. The impact would throw trillions of tons of dust, rock, and soot high into the atmosphere. This thick cloud would spread across the globe, blocking out the sunlight for months, maybe even years. This would create an impact winter. Without sunlight, temperatures would drop dramatically. Plants would wither and die, and the entire food chain would collapse. The world we know, with its green forests and blue oceans, would be plunged into a long, dark, and frozen twilight, a struggle for survival under a darkened sky. For the people who survived the initial blast and its immediate effects, life would become a daily challenge. Cities would be in ruins, and the normal structures of society would disappear. People would have to work together in new ways, sharing resources and knowledge to survive in a harsh new world. Fear and uncertainty would be constant companions, but so would the human spirit of resilience. We would look at the darkened sky not just with dread, but with a new determination to rebuild, to learn, and to ensure that humanity never has to face such a challenge unprepared again. How do we know what is out there? We have guardians watching the sky for us. These guardians are scientists called astronomers, and their tools are powerful telescopes here on Earth and in space. They work tirelessly every night, scanning the cosmos for any moving objects that come near our planet. Programs like NASA's Planetary Defense Coordination Office coordinate these efforts, creating a global network of eyes on the sky. They track every known near-Earth object, or NEO, calculating its orbit with incredible precision to see if it will ever cross paths with Earth in the future. These sky surveys are like cosmic detective work. A telescope takes a picture of a patch of sky, and then a little while later, it takes another picture of the same spot. A computer then compares the two images. The distant stars will all be in the exact same place, but an asteroid, being much closer, will have moved slightly. This tiny moving dot of light is a new discovery. Scientists then observe it over many nights to map out its precise path around the sun. The goal is to create a complete catalog of all potentially hazardous asteroids so there are no surprises. The search is getting more and more advanced. We are building bigger and better telescopes specifically for this purpose. For example, the Vera C. Rubin Observatory, once it is fully operational, will be able to scan the entire visible sky every few nights. This will dramatically increase the number of asteroids we can find and track, especially the smaller ones that are harder to spot, but could still cause significant damage to a city if they hit. We also use radar to get a closer look, bouncing radio signals off an asteroid to determine its size, shape, and how fast it is spinning. This constant vigilance is our first line of defense. By finding a dangerous asteroid early, we give ourselves the most valuable resource of all time. If we discover a potential impactor decades in advance, we have a much better chance of doing something about it. The work of these astronomers is quiet and often goes unnoticed by the public, but they are performing one of the most important jobs for the long-term survival of our species. They are the sentinels on the cosmic watchtower, ensuring that we can see a threat coming long before it ever reaches our doorstep. So, what can we do if we find a big asteroid headed our way? It might sound like science fiction, but scientists have real ideas. The key is not to destroy the asteroid, which could create many smaller pieces that might still hit Earth. Instead, the goal is to gently push it off course. We just need to change its speed by a tiny amount, just a few millimeters per second. If we do this many years before the predicted impact, that small nudge will add up over its long journey through space, causing it to miss our planet completely. One of the most promising methods for this is called a kinetic impactor. This is a fancy term for hitting the asteroid with a high-speed spacecraft. We proved this idea works with NASA's DART mission in 2022. The DART spacecraft successfully crashed into a small asteroid and changed its orbit. It was a historic moment, the first time humanity has ever altered the motion of a celestial body. This test showed that we have the technology to defend ourselves, turning a theoretical idea into a proven capability for planetary defense. Another idea is the gravity tractor. This involves sending a heavy robotic spacecraft to fly alongside the asteroid for a long time, perhaps for years. The spacecraft would not even touch the asteroid. Instead, its own small gravitational pull would gently and slowly tug on the asteroid, gradually pulling it into a different, safer orbit. This method is slower and more delicate than a kinetic impactor, but it could be very precise and controlled. For a truly massive threat, we might even need to consider other, more powerful options, although these are still being studied. This is why it is so important to study asteroids. They are not just a threat, they are a cosmic challenge that unites us all. The universe does not care about our borders or our differences. Learning about asteroids and developing the means to protect ourselves is a responsibility we all share. It is an investment in our future, ensuring that we can handle one of the greatest natural disasters the universe can throw at us. By looking up and understanding our place in the cosmos, we learn not only about where we came from, but also how to protect the only home we have ever known.